All right. Hello, everybody. I am Justin. I am one of the instructors for Intro to Android Development, and I apologize because I messed up the lecture recording earlier in lecture. I actually was recording the wrong string, the wrong screen the entire time, and so I will be recording another one right now. I'm actually in my dorm recording this, and so yeah, apologies for that. We will have that fixed by next lecture or next discussion so that I don't have to be re-recording this in my dorm and so that you don't have to wait for this to come out. But anyways, without further ado, let's get into the lecture. And so in this lecture, we will be going over the goals of this course of CS 1998, going over some intros for us course instructors, going over some course logistics, go into the meat of the lecture, which is sort of an intro to Android Studio, and we will be doing a quick demo for Android Studio to help you get started with your project, your first project. But anyways, we'll get more into that later. For now, let's just talk about the goals of this course. And so, why Android development? Well, it is a question that you need not ask me because I already asked all of you in your Google form. And so here is a word cloud of your responses from that Google form. And so obviously, one of some of your main concerns taking the Intro to Android course are to learn Android app development. Makes sense. I wouldn't have it any other way. And so through this course, we on AppDev are hoping to teach you everything you need to know to get started to, well, start developing Android apps. Obviously, the goals. Uh, Beyond just giving you some hands-on experience building Android apps, we'd also like to give you a portfolio that you can show off to whoever, interviewers, friends, whoever else, so that you can actually have something to show somebody, to show for yourself after taking this course. You will do so through our hack challenge, which we'll get to later. That is a really solid opportunity for you to build an actual app that you can put on your portfolio. And I guess one final sort of secondary objective for the course is to provide resources for you to learn more and potentially join AppDev in a future semester. So we will be going over a couple of optional topics in our bonus lectures that will cover topics that we on AppDev use on a day-to-day basis to create our apps. Moving on to some intros, as I have already said, I am Justin, and I am a sophomore on AppDev. This is my second semester on AppDev and my first semester teaching the course. I am a CS major and a potential game design minor. Currently, I'm on Eatery right now, working on an update for Eatery. There is my my core win instructor, course instructor, Corwin, and he is, I believe, a CS or E double major, and he is a junior on AppDev, and if I believe correctly, he is working on Resell, a sort of marketplace app for AppDev that we are hoping to release soon. Here are the here's the core staff for the rest of Android, and so this totals up to 11 total staff, which equates to about a 2-to-1 staff or student to staff ratio. And so we are fully available to give you all the help you may need to succeed in the course, whether that be through office hours or ed discussion. Please do not be please do not be afraid to reach out. Moving on to some more course logistics. For the course, make sure you attend lecture because lecture form our attendance form will record attendance and give you participation credit. Lectures are recorded and posted to YouTube afterwards, which is what I am doing right now. The enrollment, the class enrollment is done on Student Center, like always, and you can enroll in CS 1998-602 for 2 credits pass fail. The ad deadline is October 1st, or I believe that's should be 19th actually. at 11:49. But regardless, make sure you enroll soon so that you don't forget. And drop deadline is November, I believe it's 9th as well, at 11:59 p.m. But yeah, make sure you add that to your schedule as soon as possible. In terms of getting help, you should have been added to our ed discussion. If you have not, please send me an email and I'll make sure to rectify that for you. But ed discussion is the primary or is the hub for asking questions about this course, so make sure you use ed discussion and as well come to office hours if you ever need some more one-to-one help. We do have a lot of TAs, and so we are eager to help at every step of the way. Submitting assignments will be done on CMS. I'm sure some of you have some amount of experience working with CMS. That's where our assignment submissions will be done. Everything else about the course pertaining to the course will pretty much be done on or is pretty much documented on our course textbook at android-course.cornellappdev.com. There you'll find information about our homeworks, our curriculum, and even bonus curriculum for uh, potential overachievers, I suppose. Our course schedule consists of 6 projects in 6 lectures, one project corresponding to one lecture, each lecture, and obviously lectures are posted on YouTube. After the 6 main lectures, we will be giving our 4 bonus lectures, and all of which correspond to one extra credit bonus project. The bonus lectures will be pertaining to sort of new material, sort of unique material that pertains more closely to the stuff that we on AppDev do on a day-to-day basis, creating our apps. And at the end of the course, as a sort of final project, you will be participating in the Hack Challenge, a sort of hackathon for apps in which you will be working with iOS backend and design students in our other AppDev courses to actually work together and create an app of your own that you can show off and will be a robust, fully functional app, which is very exciting. In terms of grading, the grading breakdown is on the right as follows. 70 is passing, and most of that will be coming from your projects, your homeworks. This is a project-based course after all. Notice the 5 later homeworks are a little bit more heavily weighted than the first one, since the first is sort of just a introduction to the course, introduction to Android development, or Android Studio, I should say. In terms of late policy, you have 6 slip days total for your assignments on CMS and a maximum of 2 per assignment before we start penalizing. Moving on to academic integrity, we do take academic integrity very seriously. As you can see, the handsome Walker White is the advisor for not only the course, but also just AppDev in general. And he will be overseeing academic integrity. And so do not make academic integrity violations, and do not think that just because it's a student run course, you can get away with academic integrity violations. We will be monitoring and enforcing academic integrity just as much as any other class. Um, and after all, you are getting Cornell University credit, and so it is only fair. In terms of the internet, we do encourage you to search on the internet and search for any solutions in terms of syntax and documentation. And whilst we encourage searching, obviously goes without saying that plagiarism is bad. Do not copy others' code. In terms of partners, no partner work is allowed on our projects. We will be working individually, and we will allow some amount of limited discussion. Granted, it's done before you begin working on the assignments, and obviously do not copy other people's code. Moving on to the meat of the lecture, going into Kotlin, our programming language, which is actually built off of Java, which is why Java is so heavily valued as a prerequisite for the course. A lot of the concepts in Java will carry over to Kotlin minus some syntactic differences, and as well as some additions that Kotlin has introduced. So moving on to the I guess variables of Kotlin, they are statically typed. And so what that means is that once you declare a variable, it will have a type. That variable will have a type, and that type cannot be changed, of that specific variable cannot be changed as long as it exists. And so one cool feature about Kotlin is that uh, the type checking, or the sort of type assigned to each variable, can be implied instead of explicitly written. So both lines there will uh, compile just fine, and both will actually know that name is a string, will know that name is of a type string, even without explicitly writing it. Now you can explicitly write it with some benefits. Um, so if you do want to actually, or need to actually, declare the data type specifically, you can do it by saying colon string as, or colon the data type as shown there. Moving on to mutability. You probably noticed in the previous slide that we are using keywords val and var to declare our variables. And so val is a sort of value, whereas var is a sort of variable, in the sense that val cannot be changed, whereas var can be changed. And so if we have a val and attempt to reset that variable to a new value, we will get an error because values cannot be reassigned, whereas vars can. So changing the var name is okay, whereas changing the val name is not. Do note that making a sort of a value of val does not necessarily make it immutable. That if the object can be changed itself, it can still be changed, just not the variable or what the variable is pointing to. Moving on to nullability. This is one of the coolest features about Kotlin that separates it and makes it sort of distinct from Java. And that's that variables by default cannot hold null. They just can't hold null. So in Java, any variable can hold the value null. And that leads to a lot of problems and null pointer exceptions. And so Kotlin offers a sort of solution to this by uh, kind of forcing you to decide when things are going to be null and when things are not going to be null. And so in the first two lines of code there, those will actually not compile because by default, variables cannot hold the value null. But in the bottom line there, we put a little question mark there, and that question mark is actual syntax. That is actually how you declare a type as sort of nullable. And so that variable will actually be able to hold the value null. And so why might you actually want to do this? Well, it's sort of demonstrated by these two operators, the double exclamation point and the question mark colon operator. So the double exclamation point operator will try to sort of extract the value from the variable. And so if you write name exclamation point, that will take a nullable value name and sort of try to coerce it into a non-null value. And the thing is about doing this is that if name is null, then this can throw null pointer exceptions, which kind of eliminates the entire purpose of using non-nullable stuff to begin with. And so an alternative that you can use is the question mark colon operator, in which you can pass in a variable, and if that variable happens to be null, then you can give it a sort of default value to use instead. And in the example below, we have a name, and then the operator and default name. So if name happens to be null, it'll use default name instead of name. But if name is, not null, then it'll just use name instead. And that is a much more safe way of using nullable variables. Whenever possible, make sure that you can, or whenever possible, you should make your variables non-nullable. You should avoid the question mark, the nullable types whenever possible, because more null is more problems because of null pointer exceptions. And so that's enough about Kotlin. If you want to learn a little bit more about Kotlin, you can check out their specification online or their documentation online. And we will be holding a bonus lecture specifically on Kotlin later on. showcasing some of the more intricacies of Kotlin that make it well, frankly, superior language to Java in terms of Android development. But for now, let's hop into our IDE. The IDE we'll be using this for this semester called Android Studio. So Android Studio is built off of IntelliJ if you've ever used that. It is pretty much the exact same. You have your toolbar, editor, bottom menu bar, and project panel, just like you would in many other IDEs. And one cool feature that Android Studio supplies are these emulators. And so this allows you to test your apps on a sort of virtual device on your computer without needing an Android phone. And as course instructor, I personally don't have an Android phone. Ironically enough, I use an iPhone. And so having the emulator allows me to test apps regardless of that fact. You may see your emulator lagging a little bit. It is very common for emulators to lag, and they are just generally not as powerful as the regular phones. But it never gets in the way of performance really, and so just make sure if you ever see your emulator lagging, it's usually not a big deal, and it's more often than not just the fact that the emulators can be a little slow. For debugging, we use logcat, and so whenever in Java you would use system.out.println to debug, we will instead use logcat, specifically the log.diw and e functions. So each of these functions calls or takes in a tag and a message. So the tag is a sort of identifier for you as the programmer or the debugger to find your debugging statements because well, in logcat, there's going to be messages flooding in from everywhere. There's just going to be a ton of messages, and so your debugging message and the lines and lines and lines of debugging is most likely going to be lost. And so with that tag, you can actually search for your message or search for your tag so that you can find your debugging message. The message part is sort of the meat of your debugging statement. That's what you actually want to be uh, putting your like debugging statement in. There are four of these functions, D, I, W, and E. These each stand for debugging, information, warning, and error. Uh, you, these all pretty much do the same thing. They print out something to logcat, but you should use each accordingly for if you are debugging, printing useful information, warning, or throwing an error. Testing, testing. Okay, we are back. My headset turned off, but now we are back. Apologies. So, going into logcat, showing an example of logcat, the tag we pass into this logcat .i call is the tag string. And so tag string will allow us to find our debugging statement very quickly in the Android Studio sort of console. And so if we were to search up tag string in the search bar for the debugging console, we will find our message here and be able to say, okay, yeah, this is the statement that I'm looking for, and it printed Android. Awesome. So Android screens are called activity. The screens that you have on your app, they are called activities. And activities, in terms of code, are where we'll actually be writing most of our application logic. So whenever we need to handle user input, change stuff on the screen in a sort of complex way, we will be using activities and writing code in activities. The first activity you will see upon creating any project is the main activity. This will come prepackaged with any or any project that you make, and it's basically just a blank screen, more or less. Make sure you do not delete any of those lines of code, super.onCreate or set content view, because if you do, you will not see anything. Layouts. Moving on to layouts, these we have layouts in Android Studio that allow us to sort of lay out views. And so layouts are defined in XML and they consist of these sort of visual elements called views, which we'll get to later. And so layouts sort of structure the stuff that you will see and display to the user. It'll lay it out, sort it, uh, put it in a certain arrangement so that it can be so that these views can be displayed to the user. XML is the file, the sort of file type uh, that these are written in, that layouts are written in, and they use a opening tags, closing tags, uh, sort of code language, if you will, and each something very important to note is that each view that you define will have an ID. And so if you can see down here, we have an ID called ID text view. And so this sort of ID is how you will be communicating between your code and your layouts. So connecting XML and your your layouts, which is XML, and activities, which is Kotlin, you will be using this function find view by ID. And so find view by ID will take the view in your take the view in the layout and allow you to perform logic on it in Kotlin in your actual code. And so if you do find a view by ID and do r.id dot and then the ID that your view is in your layout, then you will be able to get that view and actually perform tasks on it. So again, find view by ID is the way that you will be interacting between layouts and activities. As we saw before, XML code is kind of complicated to write. It's a lot of kind of complicated syntax, and it's hard to interpret. And so, what Android Studio gives developers is something called the layout editor, which is a much more intuitive and uh, easy, fast way to create layouts. And so it's a very intuitive drag and drop UI, much easier than directly editing XML. And if needed, XML code files can be directly accessed, which does have its benefits, but most of the time you'll be using the layout editor. So moving on to views. So views are the sort of most basic element or the most basic form of stuff that you will be seeing in uh, displaying to the user in Android Studio. And so some examples of views are edit text, buttons, text views, and image views. And so this is a screen from Eatery, one of our most popular apps. If you look down the screen, look down this activity, you will be seeing all of these four. And so edit texts allow you to input text into the search bar. Buttons allow you to press filter buttons to filter eateries. Text view displays the names of eateries, and images display an image of the eateries. So in terms of parts of the activity, this is like your file structure. Layout files will be located in app/res/layout, and however many folders after that for how you've organized your layouts. And in terms of program files, those will be located in java/com whatever your package name is, and then your activities will be stored there. So for a quick demo, I will be just very shortly going through the sort of process of creating a new project in Kotlin and going through layout editor and whatnot. And so to make a new project, you'll want to go to File, New Project. 9 times out of 10, you'll be wanting to just go with the empty activity here. You can name it. I'll call it my test, and we can just click Finish, and it will create our project. It might take a while for the Gradle to build everything and whatnot, so no worries about that. Just hope it doesn't get in the way of the demo in any way, and it seems like it built just fine. So here's the layout editor first and foremost. So this is our main activity, the layout for our main activity. And so here we only have like one text view uh, in our layout. But if we wanted to add more, we could just go into our palette here and add some stuff. So I'm going to add a button very quickly here. And so buttons will obviously take in user input. You can have all sorts of easy ways to like drag around your buttons and lay them around. I'm just going to sort of put this button in the middle of the screen here with this text view. And in the layout editor, you can also change various properties about each view. And so I'm going to change this button into a button with an E to be a little bit more sophisticated, or maybe I'll say Jutton because it's very similar to Justin. So the Jutton instead of the button will now say Jutton because I changed the text to Jutton. And so if I want to change the ID of the button, remember that's what we use to communicate with the Kotlin files. We can change that to the Jutton, and we can refactor to change it to the Jutton. And so now the Jutton, if we were to go into XML, we could see that the ID of the button is actually Jutton. The ID of the Jutton is the Jutton. So now we can actually reference this in our activity. So our activity is where we will be uh, actually writing like the the logic for our views. And so if I were to type val the Jutton equals find view by ID, remember that's the key thing we'll be using to find the views from a layout, r.id.Jutton, then we can actually find our button. Also, we need to pass a short little, since this is Kotlin, we need to pass a sort of type here. And so just like that, we now have our Jutton, which is fetched from the layout by find view by ID. And so now we can actually do stuff with this Jutton. So if I wanted to say change the text to Jutton Jutton, I could do that. It's giving me an error because, or it's giving me a warning, but no big deal. This is just a test. I can also set an on-click listener. Don't worry too much about this, how to do this. We will go over this in future lectures. Do not worry about it too much. That is actually a topic for next lecture, but just for testing, we can say, just for the demo, for the sake of demo and for sake of testing, we can make a little debug statement here, and this will fire upon every time it is clicked, every time the Jutton is clicked. And so just for a tag, I can say Jutton debug. And so if I wanted to search for it, I could use Jutton debug. And speaking of working with it, let me fire up my emulator in the background so we can actually test this later on. We can say Jutton debug and pass in an error message. So we can say little build Gradle. We can say Jutton pressed. And so every time the Jutton is clicked, it'll say Jutton pressed with the tag message Jutton debug. It gave me an error before because I didn't quite finish the function at that time. But now, as you can see, the text has been changed to Jutton Jutton because of this line right here, line 15. And if I were to click it, well, it doesn't really do anything. That's because the log function is purely for the developer's eyes only. And so if we go to the logcat little tab down here, there are a bunch of different other tabs for building and whatnot, for like a more general console, but the logcat is where you're really going to want to be doing your debugging. And so there's, as you can see, just a lot of stuff happening here, a lot of things, a lot of messages being thrown around. And so if I wanted to find my actual my message, I could use the tag here, Jutton underscore debug. If I type it in here, as you can see, Jutton underscore debug will be found, and well, it says Jutton pressed. And so that is just a quick demo on how to use debugging and find view by ID to sort of communicate with the layouts from Kotlin. And I believe that is everything I'd like to cover in today's lecture. Again, apologies for messing up the recording. Will try not to do that again, as you could probably imagine, not ideal. But uh, regardless, I hope you find this lecture helpful. As just a little bit of a heads up reminder, homework 1 is it's due in a week about on 9/25. That's next Sunday at 11:59 p.m. Uh, we will go over more applicable stuff for the homework on Wednesday in a more thorough demo. But for now, you can look on the course textbook. Homework 1 will be delineated there, as well as homeworks 2 through 6. But for now, you can look at homework 1. It's not quite out on CMS just yet, but don't worry. You can work on it just based off of the stuff that's on the textbook. CMS is purely just for assignments, for submitting assignments. So don't worry about that too much just yet. And well, that is all I have for lecture. Thank you for watching if you are. Again, apologies for messing up the recording. And, well, thank you for taking the course. I hope we will have a wonderful semester.